Hello, my name is Ashan Chatterjee, and welcome to my LeetCode programming problem video. This time we're going to look at the problem jump game. First we're going to look at the problem description, see an example, and then we're going to look at two solutions, the dynamic programming solution and the linear solution. For each one, we're going to see an explanation and an example, and then we're going to look at the code and analyze the time complexity. You are in this problem, you are given an array of numbers, and each number represents the maximum jump length. For example, if you're currently on 3, then you can jump either once, twice, or thrice. Return whether you can make it to the end. In this example, you are given the array 3, 2, 1, 0, and 4. If you jump 2 or 1, you will always make it to 0, and once at 0, you cannot move on. So, in this case, it is impossible to reach the end. First, let's look at the dynamic programming solution. If you are at the end, then you return true, as you have made it to the end. Otherwise, go through each possible element you can jump to, and check if you can make it to the end from there, using a recursion. In this example, we're given the array 1, 2, 0, 1, and 4. You started at 1, and first you jump once to 2. Now that you're at 2, you try jumping once to 0, and since you can't get anywhere, you go back to 2 and try jumping to 1. Now that you're at 1, you try jumping to 4, and since you're at the end, you return true. Now let's look at the code. We have our driver method, and then we initialize a memo array which contains booleans. In our helper method, we keep track of our current index, and if the current index is at the end or past the end, we return true. If we have already calculated the value of this position, then we just return that. Now we iterate over the array, or we iterate from 1 all the way up to the amount we can jump, and if we can jump, then if we can make it to the end, then we return true. If we cannot make it to the end from any position we jump to, we return false. The time complexity is O of n, since every element is memoized, so we calculate each position exactly once. Now let's look at the linear solution. We iterate over the array, and for each element, we keep track of the farthest element we can reach. If we're past the farthest element we can reach in the array, then we return false. In this example, you're given the array 1, 2, 0, 1, and 4, and we initially set the farthest as 0. Now we go to the first element, which is 1, and the farthest index we can reach is the index number 1, which is the 2. Now we go to 2, and the farthest we can reach is our current index, which is 1, plus 2, which is 3. Now we reach 0, and the farthest we can reach is still 3. Now we reach 1, and the farthest we can reach is our current index, 3, plus 1, which is 4. And finally, we reach 4, and we're at the end, but we still update the farthest variable to 8. Note how at any point in the array, our index did not pass the farthest variable. We have our driver method, and keep a variable called farthest and initialize it to 0. Next, we iterate over the array, and our logic for keeping in the array is checking if I is less than or equal to farthest. Next, we update the farthest variable, just the maximum of what we had before, or the current index plus the amount you can jump. Finally, we return if the farthest is greater than or equal to the nums.length, which means if we can reach the end of the array. Since we iterate over the array once and do nothing else, the time complexity is O of n. Thanks for listening, and I hope you enjoyed.